So today we are covering 3-4 again, starts on page 138. Before we do, just to recap what we've done this chapter so far. In 3-1, we're solving systems by graphing. You just have to type 2 lines in your calculator to see what they cross. 3-2, that's where we learned to do substitution and elimination to find out where they cross. So that didn't involve any graphing. So that's another thing you'll have to know how to do. And then 3-3, we did the graphing systems of inequality, where we had to find the region that was shaded twice. Okay, and that goes right along with what we're doing today with linear programming. Linear programming is used to find maximums or minimums. Next time we'll do some actual application problems where you're maximizing things, like we talked last week. If you own a business, what are you hoping to maximize? Profit. So we'll do some problems with that next time. Today, though, I just want you to see how it works. Graphing some inequalities, finding a colored area, and seeing what a maximum or a minimum looks like. So we'll go ahead and get started on that, looking at example 1 on page 138. What they're going to do is give you 3 or 4 inequalities. You'll graph all 3 or 4 of them and find the area that all of them would shade. Okay, so it is really similar to last time. So the first inequality they have there, x is greater than or equal to 1. Y is greater than or equal to 0. 2x plus y is less than or equal to 6. Those inequalities right there are called constraints. They're called constraints. They are constraining. They're holding that shaded region. So it's kind of boundary lines on each side of a shaded region. That's why those are called constraints. And then that last equation that they give you there, that's what you're supposed to maximize or minimize, the one that has the x, y in front of it. I'm going to write that up here. So that's the one you're trying to maximize, and in this case, maximize and. The only difference between today and what we're going to do next time is you will be responsible to write all of these based on some information that I give you. But today I'm giving you all of them. All you have to do is graph them and find the area in the middle. So for that first one, what kind of line would that be? X is greater than 1 or x equals 1. Vertical line. So all you need to do, and it would be a solid line, so x equals 1 right here. So we draw a solid vertical line. Now, which way would be greater than that, to the left or the right? To the right, not a trick question. Now, last time, we went ahead and shaded here. Don't do this. We went ahead and shaded everything on that side. For this one, since we have 3, it's probably better not to shade and wait until you know what the region's going to look like before you do any shading. So what I would do, and this is why colored pencils are probably good for this, you can just put an arrow, meaning that's the side of that line that you're going to shade when it is time to shade. So then y is greater than or equal to 0. What kind of line would that be? Y equals a horizontal line. And y equals 0 right here, and it's also equal to, so it would be another solid line. So there's your y is greater than or equal to 0 line. And if it's greater than 0, would you shade the top half or bottom for that one? The top half. So again, just put an arrow. So if we were done, if those were the only 2 we were going to graph, we would just color in this area. But we still have this other one. What do we need to do first in order to get that one graphed? What would you be doing by moving your x? What's the point? What are you trying to do? Getting y by itself. Yeah, solve for y. So we would have to subtract the 2x. So y is less than or equal to negative 2x plus 6. Now, you can type all three of these in your calculator. Those first two you should be able to do pretty easily without. But that last one, if you want to type it in, it'd be a good idea to go ahead and type them all in, because it would show you what this shaded region is going to be at the end. So if you hit your y equals and type that in, I'll go ahead and just graph it. And again, I would do that in your calculator because it's going to show you which side of that line to graph. You don't have to do your test point like we talked about last chapter. And this one is shaded on the bottom side. Once you got that one typed in, it would be shaded in here. So from the red line, you're shading this way, the green line, you're shading up, and the blue line, you're shading down. So that is where you would color in on this problem. And it doesn't have to be completely blackened. Just showing that that is the region that's bounded by those constraints. So we haven't covered anything new. Really, you've done all this before. You've even done the one that had 3 or 4 equations in it at the end of section 3. So what's different today, your maximum or your minimum will occur at those vertex points. Those are the points you're trying to find. The points on the edge of the colored area. This is called your feasible region. The colored area is your feasible region. So when the book says feasible region, or I do, that's what you need to know. I'm talking about the area that's colored in, the area that's bounded. So the corners of your feasible region are the points you have to plug in to that equation. So what's one? These are called vertex points. What's one of them? What are the coordinates of one of the vertex points?
4, 1.
Not 4, 1. What? 4. That's one of the points we got to plug in. 1, 4. Do what? What was that one somebody said? 1, 0. And what's the other one?
3, 1.
3, 0. 3, 0. There you go. So those are the three. We made a triangle. Obviously, that's what the feasible region is. So you should have 3 vertex points or vertices. So you just plug these 3 in up here. See which one gives you the most. See which one gives you the least. Maximum and minimum. So in 3, x plus y, we'll plug in that first point. And what would we get? 7. Plugging in that other point, what would we get? Middle point. 3. And the last point. So your answer, because it did actually find maximum and minimum. Maximum of 9 at 3, 0. Minimum of 3 at 1, 0. So that's your answer. That's your final answer where the maximum and the minimums occur. And again, on your calculator, you can actually get it to just shade that this colored region in here, which I'll show you on the next one. But you can get it to graph this exactly as we have it up here, and then you can pick your vertex points off your calculator. Still have to graph it on your paper, but you can use your calculator to figure out where it's at.